All right, so we'll probably just try to go ahead here and do the next ones. I don't know how many I'll get through, but we'll try. Oh, let's start with B. So, this is not a difference of square. Those were the first questions. Here, 4, I'm going to do 2 and 2. X plus 1 squared, I'll do x plus 1 times x plus 1. That way the left side still preserves the left. The right side needs 25. I'm going to do 5 and 5. By the way, I noticed that 4 and 25 are perfect squares. So that's why I did square root of 4 is 2 and 2. The square root of 25 is 5. So that's why I did those. However, I do also notice that the inside is negative, but the outside number needs to stay positive. So I'm going to make these both negative. So what are my diagonals? That diagonal is a negative 10 x plus 1 and a negative 10 x plus 1. If I add those, I get negative 20 x plus 1s, which is my middle term exactly, negative 20 x plus 1. So I have this as my factor and this as my factor. I'm going to write this as a 2x plus 2, 2x plus 2 minus the 5. And the other one is a 2x plus 2 minus the 5. So I can add some like terms, 2x, and then this and this is a minus 3. And this is a 2x, also minus 3, so I'll write 2x minus 3 all squared. So that's how we're going to do this. This is done exactly the same way, but you end up having to do this little bit of Math 9 stuff, expanding this in, the 2 in this case. Okay, so let's try, I'm going to go on to C, and then I'll go back to A. So I do notice, and okay, 49 is perfect. I'll do 7 and 7. 36 is perfect, so I'll do 6 and 6. So I'll just try that, and we'll see. I'm going to erase this stuff here. Okay, so 49, I'm going to do 7 and 7. 36, I'm going to do 6 and 6. And then this left side is x minus 2 squared. So I'll do an x minus 2 times x minus 2. This 36 is just 6 and 6. So my diagonal is 42 x minus 2 and another 42, and that one, x minus 2, which is, if you add them, I have 84 x minus 2s, which is exactly what I have here, 84 x minus 2s. So that checks out. So I've got this one and this one. So the first one is going to be 7x minus 14. And then there's a plus 6. And another 7x minus 14 plus the 6. They're both the same. I can add some like terms. The 7x is there, but negative 14 plus 6. Negative 14 plus 6 is going to be negative 8. And there are 2 of them. So I'll square that. There we go. Well, it simplifies a lot nicer. 7x minus 8 all squared. So I will now take a look at letter A. I'm going to put a 1 here. So I notice that 1 is a perfect square, 1 and 1. 25 is a perfect square, 5 and 5. So that's nice. I will try that. There's a 1 and a 1 and a 5 and a 5. And then this left side here is an x minus 1 squared. So I'll do x minus 1 times x minus 1. Hopefully you can hear me and not the teacher across the hall that's just yelling. Now, the middle term here is minus, but the outside is positive. So I need this to be positive, but I'm going to make them both negative. That way it stays to be a positive 25, but my insides will be negative. So this diagonal is a negative 5, x minus 1. This one is a negative 5, x minus 1, which if you add them will get you negative 10, x minus 1s, which is what I have. So I've got this one and this one. So 1x minus 1, and then a minus 5. And this one is a 1x minus 1, minus 5. Now they are both the same. So 1x minus 6. And like I said, they're both the same. This is a 1x minus 6. So I'll just square that. So that's the end of these three, but I'm going to go right on to the other ones. So I don't think this is any more difficult than normal factoring, which is why I choose to do this grid method. This grid method because it allows me to keep things consistent. All right, so another one. Let me put a 1 here. Now, 1 is a perfect, 6 is not perfect. So, okay, I can't use that square root trick, but, I mean... Oh, wow, look at how many there are. I had no idea. So I'll do a couple of them, and then I'll do some more in another video. Let's take a look here. So this needs to be a 1 and 1. And then this is an x plus 1 squared, so I'll do x plus 1 times x plus 1. And 6 will be a 3 and a 2. But my diagonals are going to be, that's a 2. 2 times 1 is 2. That's a 3. 2 plus 3 is 5, and I need negative 5. So I'm going to make them both negative. So this diagonal is a negative 2, x plus 1. This diagonal is a negative 3, x plus 1, which if I add them gets me negative 5, x plus 1s, which is exactly what I have. So that's one factor, and that's the next. So the top one first, 1x plus 1, 1x plus 1, and there's a minus 3. So a minus the 3. And then 1x plus 1, 1x plus 1, and then there's a minus 2 here. Minus 2, these are not the same, so we can do them separate. There's a 1x, 1 minus 3 is minus 2. And this is a 1x, 1 minus 2 is a negative 1. And that's it. Now it is factored. The math here, like the numbers and stuff that we're doing, are quite small. We're not dealing with really large numbers, but and it's pretty consistent with what we've been doing all along. So let's do another one. So this is a 1 in here, so I'm going to do 1 and 1, and I'll do an x minus 1 and an x minus 1, so that I get an x minus 1 squared. This is an 8, maybe 4 and 2, but I notice the inside is negative, so I'm going to make both of these negative. That way it still preserves that they multiply to positive 8. So this diagonal is a negative 2, x minus 1, and a negative 4, x minus 1, which add up to negative 6, x minus 1s, and that is what I have in the middle. So let's just put some brackets. That's one factor, and that's another. So I get a 1x minus 1. Oh, and then there's a minus 4. And then a 1x minus 1. And a minus 2. So I've got a 1x, and these can become a minus 5. And then I have another 1x, and these can become a minus 3. So that is my answer. 1x minus 5 times 1x minus 3. That is fully factored. So I will zoom out. I just did 5 questions, and we got another 4 more to go. I would recommend that you try at least D and E. C looks like it's a lot bigger of a question, but I would try D and E first and see what you can do, and then watch the videos, and I'll go through them as well.